Manda Rimbai is there. Okay, Masood Jahan is also there. Samir Verma, Shiv Narayan, and Sulekha. Okay. Good evening once again, and we'll immediately start with our session. Okay, all of you
Yes, sir.
are you ready?
Yes, sir.
Okay, so let us move to the folder. Okay, so we are going with ETAB now. So I'm starting ETAB by double clicking on the icon. Yes, the initialization process has started, and now we are here. So the recent model example for B19, that was our model. So I'm clicking, so it will get opened. So this process now you must have practiced. Hello.
Yes, sir.
Yeah,
Yes, sir.
yeah, that's nice. Mm, let me get it. Okay. So whatever we have completed is that we have gone through the material definition, section properties. In section properties, we have defined frame sections, slab sections, and we are yet to define wall sections, but that I will take it a bit later. Then in defining, also we have defined load patterns. Let us see. Yeah, we have defined dead load, live load, and STL. Already the two are always there, and STL is to be defined by you. STL means superimposed dead load. Okay, so anything which is not a part of self weight, but it is a dead load, that you can include all those things: wall load, floor finish load, ceiling, any POP or any ceiling load or any other load which is permanently there, which is not a live load, that will be included in superimposed dead load. Okay, the self weight will be included in dead load. Okay, now let us see. So we have defined, or we have assigned the loading on beams. So let us see. We have applied the loading. I can check it over here. So the loads under load category, you can see that, and we have also seen how we can define or how we can see the loading UDL on beams by going into the elevation. Let's go in any elevation. So let us say I will go elevation 3, and under that I will display load assign frame and then STL, and click OK, and you will see that the loading is there. So this way you can apply the loading on all floors. Okay, now let us go and see the first slab. So here it is a slab. Okay, now if I right click on any slab and if I see the load column, under that load category, I don't have any loading on this. Now, what is the loading that you can apply on slab? Anyone?
Dead load. Dead load.
Dead load, that self weight is the part of, because we have modeled slab, so we don't have to consider self weight of the slab, right?
Yes, sir.
Yeah. See, here you have modeled the slab, and slab is an integral part of structural element. So in modeling, we are modeling all those elements which are integral part of structural behavior. Maybe for footing, that means support, then column, beams, slab, or walls. Walls we have not defined. We'll define the walls later on, but walls are also structural part. So all that structural elements will be defined in ETAB model. Non-structural parts, which are partition walls or maybe any additional loading on the floor in the form of floor finish or in any other form which is not uh, part of the element, so that will be assigned through your assigned loading. Okay, so right now if you see anywhere you don't find any loading on any slab, you don't find any loading because we have not applied. Now we want to apply the loading on slab, and loading on slab, when it is a uh, gravity loading, you will see that self weight, so that is a dead load, which will be, let's say, self weight. This will be calculated at the time of analysis by the software. So we don't have to worry about dead load. Then live load. Now how you will apply the live load? Where
Yes, sir.
from you will get the live load intensity? If you are following Indian code, then we will have for live load. If you want to see the standard live load loading on any floor, whether it is commercial, whether it is residential, whether it is hall, institutional, or mall, or parking, all that loading you will find in IES 4875 875
Part 2.
part 2. Right. So it is assumed that you know this. Okay. So this software, any software will assume that you know this, because this is not a part of software. It is a part of your civil engineering understanding. If you are following ACI code, then you will have to go and see what are the live load that they have defined, or European code, or any other code, maybe Japanese, Chinese, Australian. And if your country does not have loading standards specified by the codal committee, then they might have been using some different countries code. Right now I will say that Nepal is following, right now they are following our code. Okay, whatever is specified in Indian code, they are following that. But later on they will define their own. Okay, simply then if you go in Arab countries, maybe UAE or any other countries, Saudi Arabia, so then that one, Oman, etc., Muscat, they are following uh, they are following British code as well as ACI code. So accordingly you will have to learn the or you will have to go through the codal provisions. So right now we are concentrating on Indian circumstances, and that's why I will say that you have to know IS 875 part 1 for dead load, 875 part 2 for live load, and IS 875 part 3 for wind load. Okay, clear?
Yes, sir.
Okay. Now, this live load category under residential, we are following 2 kilonewton in 2 kilonewton per square meter for rooms, residential building, maybe bedroom, living room, kitchen, etc. Then for balconies and passage, they say that subjected to overcrowding, the loading category or the intensity that you have to provide is 3 kilonewton per square meter. If you are having some parking, it depends on whether it is a mechanical parking or simple parking. It depends, and it varies from 5 kilonewton to 8 kilonewton per square meter. Right. So these are different so if you go through this, you will get it. Okay. So accordingly you will have to go for that. Now we will apply the loading on all slabs. I will show one particular slab level, and you can apply it everywhere. Yes, is this much clear? Hello.
Yes, sir.
Yes, sir.
Now, when you are going for any superimposed dead load, then you will follow STL. Okay. So that will be applied under STL category, and it depends on floor finish that you are providing. The floor finish that you are providing in our 875 part 2 says that it is something from 1.25 to maybe 1.75. It varies from this. So minimum is 1.25 or 1, and maximum is 1.75, or you can say 2. So this is for normal floor finish. Okay. Then if you are going for waterproofing, then you will have to consider the thickness of waterproofing. Or if you are going for any say terrace gardening, then how much soil you are providing, what is the thickness of that soil that you are providing over the roof. It depends on that, and based on that you will calculate and you will apply. So the category, the application category is HDL for all other loads which are permanent. Once they are placed, they will be permanent. And for live load, the category is live load. Let us apply the live load first, and then we'll see how to apply STL, how to calculate STL, and whether you will follow this or you will follow this, how the decision will be considered. Okay.
Yes, sir.
Yeah. So one by one, we'll start with that. And let's say I want to apply a loading. Let's say I will consider this as a balcony, this as a balcony, this as a balcony, this as a bathroom, and this is also a washroom, bathroom, etc. Right? I'm just considering, and then I'm applying. Now, when you are having your practical model, then you don't have to consider, because right in front of you there is a architectural drawing. Right? Clear?
Yes, sir.
We are going with some hypothetical model. That's why we are considering that this is living, this is bedroom, this is kitchen. But if you are having architectural plan with you, you don't have to consider, because the architect has clearly mentioned that this is the area which belongs for bedroom, living, passage, balconies, staircase, all that is defined. So accordingly we will apply it. So let us consider all these rooms. So I will click, I will see that the first thing is that if you don't see here, if you don't see that one story application or similar or all, that means something is something is displayed in the assign. So that to remove that, you have to go to assign and clear display of assign, and then you will see that that option is on. आप में से कितने लोग ये डिफिकल्टी से गए हैं? हेलो. When there is some display, this you don't see, because this is the hidden. Okay. So that can be visible only when you will remove that display. Right? Hello.
Yes, sir.
Yeah. Now you can see this one story option is on, and so I'm going to apply the loading on every segment, uh, one story uh, one story at a time. So I will select. So how to select? Go inside that panel and click on that. So left click will see that it is selected, and here you will see that one cell is selected. Then second, third, fourth, fifth, sixth, seventh, eighth, nine. Let's say all these are having a live load intensity of 2 kilonewton, because they are the panels of residential floor, rooms, maybe living, etc. Okay. Then after selecting, you can go to assign. Now as you have selected a shell, you will have to go into shell loads.
Load.
Okay.
Okay, sir.
Previously we were going in frame loads, but now we will be going in shell loads,
Yes, sir.
and then we'll click on uniform. The moment uniform is clicked, you will see that the load pattern that you have defined will appear over here. Accordingly, you will select live load, and then you will provide a
2
loading
kilometer.
magnitude that you want to assign. Now, this is your responsibility. Software will not give you the idea that you should apply 2 or 2.5. Software will say that whatever you say, I will apply. Okay, so let us say 2.0, and now I'm not applying minus because it is a gravity load. Okay, you can see direction is gravity, and that's why it is applied downward. Then replace existing load and apply, or you can say okay. If you click OK, the window will be closed, and if you say apply, the it will apply, but window will be always there, right? Then I will choose this. Let's say this is my washroom. This is also a washroom, and I will apply a loading of say 1.5. Okay, and again I will apply it. You can see 1.5, 1.5. You can see 2, 2 over here, and now this is also a passage. So this passage is not subjected to overcrowding. So I will apply only live load of 2 kilonewton. Apply. Then I will select the balcony. Let's say these are the balconies which are subjected to overcrowding, and as per our codal provision, the live load that you have to consider is 3 kilonewton. So I am applying. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now if you right click on any, and you can see now under load category 2 kilonewton is applied, and the pattern is live. Okay. Now we'll go to floor finish. Okay. For floor finish, let's say now there is one simple idea to draw to find out the floor finish. But for that, you must know the construction practices, and how the flooring is applied. What is the intensity of floor, or self weight, what I will say, a wet density of the various materials, and then you can define. Let's say we'll go with a section. Let's say this is your slab. Okay, so this is the thickness of your slab, and let's say it is 125. So I don't have to consider self weight because it will be calculated by software at the time of analysis. And then let's say I want to apply a flooring over here. So for that, I'm applying a mortar, a screeding of mortar, and that is something around say 50 mm. Okay, and over that, I'm having a tile, thickness of tile. Let's say thickness of tile is thickness of tile is something around say 20 mm. That depends whether you are using lightweight tiles or manufactured tiles, or you are using natural tiles. Maybe that of granite or marble, Italian marble. So the thickness you may assume something around 25. Okay, and below this slab you are applying a plaster. Okay, so the thickness of plaster is say 15 mm. Okay, so this part is built in, so I don't have to worry about this part, which is a thickness of slab, and this is applied from the bottom, say ceiling. So what is the total thickness? 50 plus 25, 75 plus 70, 15. How much it is?
90.
Let's say 90 mm. Now, right now I am considering the density of all as 20. So 20 kilonewton per cubic meter is the density multiplied by thickness,
90.
that is in mm will be 90 divided by 1000. Okay, right?
Yes, sir.
So how much will be? It will be 20.
1.8.
Huh?
I think 1.8, sir.
Yeah. So 1.8 kilonewton per square meter. So this way you can think. Now this again depends how much screening that you are applying. Sometimes you may not be applying screening of 50 mm. Only 20 mm screening is more than enough. Then plaster maybe 10 mm, and the thickness of tile maybe again 10 mm. So that's why code says that it varies from 1 to 1.5. Got it?
एक्सक्यूज मी सर।
Yeah.
सर ये समझ में नहीं आया सर, ये 90 कैसे आया सर?
15 is the thickness of plaster.
यस सर।
50 is the thickness of mortar screeding, and 25 is the thickness of tile. That is what I have assumed. You have to go through that calculation. This calculation varies. Okay. So if you are applying a 12 mm plaster, then you will consider 12 mm. If you are applying only 40 mm screeding or 25 mm screeding, then that will be 25. And if you are having 10 mm flooring thickness, then that will be 10. 1 minute. Hello. क्लास चालू आहे, फोन करतो. चालेल. हो. Okay. So this
Okay, sir.
90 that I have calculated, but it depends on what data you are getting from the architect.
Okay,
Clear?
sir. And from where this 20 has come, sir? 20?
20?
हाँ, 20 multiply.
20 is the self weight, this weight density of that material that you are using. Cubic
Okay, sir.
kilonewton per cubic meter.
Okay, sir.
See, normally this weight per cubic meter of the flooring tile is varying. Then you will have to get the manufacturer's data. Then plaster, you know that you get the wet density of plaster if you follow IS 875 part 1. Okay. For various construction material, they have given you the density of that material. So roughly it is in between 18 to 20. For safety, I have considered 20. Clear?
Yes, sir.
Some of you may say, no, sir, 20 is not correct. When I have gone through the IS 875 part 1, but somewhere it is 17.5, somewhere it is 18.2. I have considered higher because I don't want to go on unsafe side. Right? And that's why code says that if you don't calculate the superimposed dead load on any floor by this fundamental calculation or basic calculation, you may refer it from 1 to 1.5. Clear?
Yes, sir.
Yes,
And
sir.
also remember one thing: in civil engineering, nothing is exact. Everything is approximate. आप लोग बोल रहे हैं कि सेल्फ वेट ऑफ reinforced concrete is to be considered at 25 kilonewton per cubic meter. That is your assumption. It may vary from 24 to 25. So which one is correct? Everything is correct and everything is approximate. And that's why I always say that in civil engineering, we are not interested in getting the exact answer, because exact answer nobody knows, right? Are
Yes,
you
sir.
getting this? This concept is very important. See, see some loading. If I consider higher loading, what will happen? My design will be conservative. It will be a little bit costly than someone else, but that is okay. I'm on safer side. I'm not on unsafe side. And the variation in the costing, let's say you are going to construct a bungalow for you, and someone has given you the cost of bungalow as 25 lakhs, and someone has given you 25 lakhs point 25.50 lakhs. So that is 50,000. But if the person who is having higher value is reliable, then you will say that okay, मैं अपने लिए घर बना रहा हूँ 50,000 से मुझे कुछ फर्क नहीं पड़ता, मैं रिलायबल आदमी को काम दे दूंगा. क्लियर हो रहा है?
Yes, sir.
Yes, sir.
Yeah, so that is very important. So in civil engineering, right from our design step number one, everything we are on the basis, we are doing the things on the basis of some assumptions. Nothing is clear, exact. Concrete का density कैसे निकालेंगे आप? The concrete is created at site. It is not created in the factory. So that density may vary. If that concrete is porous, the site quality is a little bit substandard, then that it will not have that quality. Then density of bricks, कैसे निकालेंगे? Bricks are manufactured at every thing, and the things are not mechanically controlled. तो ह्यूमन तो हो सकता है ना, कहीं पर उसका डेंसिटी ज्यादा है, कहीं पर कम है. तो द all things are approximate, and that's why I always say that every design is correct and every design is wrong, because what is the definition of correct and wrong? It depends on that. If you are defining the things on the basis of only economy, then the person who is giving you conservative design may be wrong for you. But the same way, some person or someone else is uh, uh, the criteria of him is stability. Then that overestimated cost is good for him. He says that that is correct, right? Clear?
Yes, sir.
तो
Sir.
मैग्नीट्यूड, हाँ बोलो बोलो. मैग्नीट्यूड के चक्कर में हमें नहीं फंसना है. वी आर कॉन्सेंट्रेटिंग ऑन द कंसेप्ट. हो सकता है आई विल कैलकुलेट 2.1, यू विल कैलकुलेट 2.5, और समवन एल्स विल कैलकुलेट 1.9. एवरीथिंग इज करेक्ट. Depends on what criteria that you are defining which are valuable for you. If you are ready to take risk, आप बोलेंगे नहीं सर मुझे इकोनॉमिकल डिजाइन चाहिए, थोड़ा रिस्क रहेगा तो भी चलेगा. In that case, you may work on light density designs, or light density material, then lightweight, then small bending moment, and lesser size, and hence lesser weight. So everything is as per your assumptions. Clear?
Yes, sir.
So the fact of the story is that whatever loading that you are considering is correct for you. It may not be correct for someone else, but that doesn't mean that you are going wrong. Okay, then we'll go for application of floor finish. Let us say I will consider.
एक्सक्यूज मी सर.
Yeah.
सर अगर ये अभी यूडीएल कंसीडर किया है सर, मान लो अगर यहाँ पे कहीं पॉइंट लोड हो किसी स्लैब के बीच में, उस केस में फिर क्या करेंगे? जैसे अगर एडिशनल कॉलम इंसर्ट कर दिया सेंटर में, इस टाइप से कोई पॉइंट लोड हो तो फिर?
See, point load slabs are not designed for resisting point load. वहां पे थोड़ा अरेंजमेंट अलग होता है. then you will have to apply, you will have to create some additional support below that point. Let me understand where from that point load will come on slab. Okay, we'll go through that because वो बिना समझे आगे जाने में कोई मतलब नहीं.
एक मिनट भाई.
See, this is your slab. Okay, this is your columns. Where from that point load is coming in picture? Let me decide that. Yes, anybody? Yes. कहां से आएगा वो तो पहला ढूंढना पड़ेगा ना. हेलो.
फ्लोटिंग कॉलम.
फ्लोटिंग कॉलम स्लैब पर नहीं सपोर्ट होता, पूरा स्लैब गिर जाएगा. It is supported from the beam. See,
और द
if,
बीम.
yeah, see, this is the boundary, and this slab is transferring the loading on it on the supports, on the beams. जैसे बीम पर लोड ट्रांसफर हुआ इफेक्टिवली फ्रॉम स्लैब, द आई विल से द ड्यूटी ऑफ स्लैब इज ओवर. क्लियर. अब वो लोड बीम का ड्यूटी क्या है? द बीम विल ट्रांसफर द लोड ऑन कॉलम. जैसे वो इफेक्टिवली ट्रांसफर कर रहा है, द ड्यूटी ऑफ कॉलम इज ओवर, duty of beam is over, and now the column is supposed to transfer that load on the column
Foundation.
below, then below and finally at foundation. So that is the load path. See what is happening in this slab. If I see, let's say this is my 5 meter length, and let's say this is 2 meter. In that case, it will be divided like this. So this much part will transfer a loading on this beam, and this part will transfer a loading on this beam. So this beam and this beam is having very small load in this area, very small, or you can neglect. So 50% loading on the slab is transfer on, let's say this is my beam number 1, and remaining load is transferred on beam number 3. Okay, so beam number 2 and beam number 1, beam number 4, let's say 1, 2, 3, 4. So beam number 2 and beam number 4 will not receive major, or they will receive very minor loading from the slab. Okay, clear?
Yes, sir.
Now the question is that where from that load is coming on slab, that is point load. That is the question. Okay, let us consider this. So this is your slab, and let us say that you are providing, or this slab is supposed to resist the flow wall load of this length.
AVUDLE.
Yeah, and below there is no beam. Below there is no beam, right? ये समझ में आया?
Yes, sir.
ये बिलो बीम नहीं है, ये वॉल के नीचे. तो
ठीक है.
this UDL, if I say this is the UDL, say this is your wall, which is you are constructing wall on slab, but below the wall there is no beam. So this slab will, if you are considering this load, then this load will become, let's say you are defining 1 meter wide, then you will see that the loading on the slab will be point load. ये पॉइंट लोड आएगा बिकॉज ऑफ दिस 150 थिक वॉल ऑन द स्लैब. क्लियर?
यस सर.
But normally such things are avoided. एक्सेप्शनल केसेस में वो करना पड़ता है. उस चीज में क्या करना है वो हम बाद में देखेंगे. राइट नाउ विल गो विथ नॉर्मल कंडीशंस. एबनॉर्मल
सर
कंडीशन. या
सर ये पॉइंट लोड आपने इसलिए कहा ना क्योंकि जो इस वॉल की विड्थ है, जो थिकनेस है, उसके जो उसकी वॉल की जो विड्थ है वो ज्यादा है थिकनेस के कंपैरिजन में.
नहीं नहीं नहीं.
है
लेट
तो
मी.
सर ये है तो यूडीएल ही सर वो वॉल तो.
नहीं नहीं, वॉल यूडीएल है.
हाँ
See, let us see. See, you are defining 1 meter wide strip. See how you are designing a slab. You are considering 1 meter wide strip. Yes.
यस सर.
And then you say that this is let's say this is your L. Then you say that this is my beam, which is this beam, and this is another beam. So that I am drawing it over here. Okay. Right. And then you are having a wall. You are having a wall something like this. So this much thickness ये यहाँ पे आएगा. तो ये कॉन्सेंट्रेटेड लोड हुआ ना.
सर. ओके नाउ आई अंडरस्टूड सर.
हाँ.
समझ गया. वो आपने 1 मीटर वाइड स्ट्रिप के कंपैरिजन में उसको पॉइंट लोड
नहीं नहीं,
जब.
slabs are always designed as a 1 meter wide strip.
ओके
यस सर.
Clear?
ठीक है सर. सर एक और डाउट था.
हाँ
वो सर आपने जो पिछली बार लोड अभी इससे पहले लोड डिस्ट्रीब्यूशन किया था ना आपने,
हाँ.
50% लोड बड़ी बीम की तरफ जा रहा था बड़ी साइज में, जो
Right.
लोड डिस्ट्रीब्यूशन आपने किया था.
ये
हाँ
ये
हाँ ये 50% जा रहा था.
राइट.
तो मेरा ये था कि ये छोटे डायमेंशन की तरफ क्यों नहीं जा सकता 50%.
आप कहाँ से हो?
सर मैं राजस्थान से हूँ.
राजस्थान से हो. मान लो आपको
जे-
दिल्ली जाना है तो आप
हाँ.
मद्रास होके जाओगे क्या?
नहीं
चेन्नई से जाओगे?
नहीं नहीं.
नहीं नहीं
डिस्टेंस
यार,
ज्यादा पड़
जयपुर
जाएगा
से.
सर.
अरे जयपुर से चेन्नई के लिए फ्लाइट है, वो पकड़ लो. फिर चेन्नई से दिल्ली के लिए फ्लाइट है, वो पकड़ लो.
नहीं सर
जाओगे?
डायरेक्ट जयपुर से दिल्ली जाएंगे.
सीधा जाएंगे ना, शॉर्टेस्ट रूट.
हाँ हाँ.
So the load also goes through find out which is the nearest support.
ओके.
तो वो ऐसा घूम फिर के थोड़ी इधर जाएगा. वो तो सीधा इधर ही जाएगा ना.
नहीं नहीं सर मैं ये पूछ रहा हूँ ये वाली इस वाले डायमेंशन की तरफ नहीं जाएगा क्या ये जो दूसरी तरफ डायमेंशन है, ये छोटा
ये
डायमेंशन है.
इसीलिए मैं बोल रहा हूँ इधर का ही थोड़ा लोड जाएगा, थोड़ा सा. ये थोड़ा सा जाएगा. ओके, आई विल शो यू द डायग्राम. See, I am drawing a slab something like this. Okay, so all four sides are beams, and let's say this is my 2 meter, and this is my 7 meter. Okay, and आप यहाँ पे खड़े हो. मान लो आप यहाँ पे खड़े हो. आपको यहाँ भी आप जा सकते हो, आप यहाँ भी जा सकते हो, आप यहाँ भी जा सकते हो, और आप यहाँ भी जा सकते हो. कहाँ जाओगे?
जो नियरेस्ट पॉइंट होगा वहां जाएंगे सर.
नियरेस्ट पे जाओगे ना.
हाँ सर.
मान लो आप यहाँ पे खड़े हो, तो आप इधर जाओगे. अगर आप यहाँ पे खड़े हो तो इधर जाओगे, और यहाँ पे खड़े हो तो इधर जाओगे, because all four sides are having the support. You can let's say you are having four different places where you are safe. Clear?
Yes, sir.
Now that's when theoretically what happens. Let's say if this is your panel. Let's say this is your panel, and let's say this is 5 meter, and this is 3 meter. Now, if I draw, I have done it. I have not done it properly. Let me do it. Let's say this is 3 meter and this is 5 meter. Okay. If I get alpha, which is aspect ratio, which is long side versus short side. So if I get 5/3, it is less than 2. Okay. Under these circumstances, the load path will be followed like this. So the load having in this area will go to this beam. Load having in this area, or the load in this area will have a support this. Then third will have this area will transfer loading on this beam, and this is your fourth. It will pass to this. And there are ways. So if you go for two-way action, okay, so you will see that this is, I will call, let's say this is the triangle. Then this is Lx by 2, whatever is Lx. Lx by 2. This is also Lx by 2. Then this is also Lx by 2. And not Ly by 2. It is also Lx by 2. And remaining part. So on this long beam, you will have a trapezoidal shaded area will be supported by that beam, and short beam will have another area. So this is okay. So this area will be supported by this beam. This area will be supported by this beam. This area number 1 will be supported by this beam, and area number 4 will be supported by this beam. So this is a two-way action, right? Clear?
Yes, sir.
Now let's say you are having another criteria. Now this is 2, and this is 5. Then if I find out the aspect ratio, which is 5 by 2,
Greater than 2.
which is greater than 2. In this case, there will be assumed line will be this, and entire area, the load from this area will be transferred on this beam, and load on this area will be transferred on this beam. Actually, very short area of this type will be transferred on this beam, but theoretically we say that it is so minor or so that we can ignore. And that's why I always say that in civil engineering everything is approximate. Actually speaking, you will see that this much area should this beam should support this, and it is actually supporting. But for analysis it becomes a little bit lengthy, and we are not interested in finding the accurate exact result. Not accurate, exact. We are satisfied with approximate results, so that we will be on safer side. Clear?
Yes, sir.
Okay. So we'll concentrate on now ETAB. So let's say here I want to apply a loading of STL, and you can see that I'm selecting 1, 2, 3, 4, 5, 6, 7, 8, and 9. In all 9 have, I will say that okay, this will also be considered, and I will say that the loading on this STL in the category STL, I want to apply a loading of 1.5. So how I can apply? Go to assign, go to shell load, go to uniform. Under uniform, now select the case STL and apply the loading as 1.5 and apply it. Clear? Okay. Now this is my balcony. This is my balcony, and this is also my balcony. And normally balconies are subjected to something around 100 to 150 sunk. Let us consider 100 sunk. See what is the direction. See, if you are having a normal slab, a balcony slab is supposed to have something like this. And this is your normal slab. This much part is sunken in construction because we want to have some MEP, that nani trap or whatever that plumbing requirements. And after providing that, we are filling this with BB, brick bed coba. So let's say BB. So if this thickness, now let's say I'm considering the thickness as 100, and then here there will be tile, then here there will be tile, here there will be a plaster. So this 1.5 plus this filled up loading, so 100. So I will say that self weight of this or wet density of this filling, I'm considering 20, or you may consider 18. 18 multiplied by 0.1. So it will be 1.8 plus the floor and plaster, you may say it will be something around 1.2. So finally, you will see that under balcony, which are sunken, you will have to apply loading of 3 kilonewton under the STL category. Clear?
Yes, sir.
Now this is how I calculated, but it will depend upon how much thickness that you are providing. Sometimes it may be 200, 300, sometimes it is 450. Accordingly, this load will increase. Or if you don't have that sunken part, then it will decrease. Clear?
सर इसको एक और समझा दो.
ये संकन क्यों होता है, समझा?
नहीं सर, यहीं से तो नहीं समझा.
नहीं पता?
नहीं सर.
ओके. जो बाथरूम होता है या बालकनी होता है, वहां पे ड्रेनेज पर्पस के लिए आप कुछ नानी ट्रैप वगैरह बिठाएंगे? यस ट्रैप, टी ट्रैप. यस.
यस सर.
सो वो बिठाने के बाद उसको अगर 100 थिक हाइट लगता है, तो योर पोर्शन ऑफ दैट टेरेस विल गो above the floor by 100 वो स्टेप अप होगा ना?
यस सर.
It will not be at the level of your floor. तो उसके लिए already in concrete, when you are going for concreting, it has been provided a sunk, and that sunk is by 100 so that after providing a trap over here, let's say this is your trap which is going back, and this will be connected to your plumbing services. तो द ड्रेनेज फैसिलिटी विल बी क्रिएटेड, क्योंकि यहाँ आपका वॉशिंग वगैरह कुछ एक्टिविटी होता है ना, तो पानी
हाँ
कहाँ
सर,
जाएगा?
ड्रेनेज में ही जाएगा सर,
हाँ, तो उसके
पाइप
लिए
के थ्रू।
प्रोविजन अगर नहीं करेंगे तो नहीं जाएगा ना।
हाँ सर।
तो वो प्रोविजन करने के लिए देर इज अ sunk part of 100 mm, 150 mm, 200 mm. That is the discretion of architect.
ओके सर।
Okay.
ओके सर।
Now you cannot keep it open. That's why you will feel it, because later on you need a flat surface from your room to your bathroom or from your room to the balcony. Clear?
यस सर, यस सर।
So the feeling load you have to take into consideration for design, and that's why this is the additional load. This is your usual load of flooring, and finally it is coming out to be 3 kilonewton. So this quantity may vary. It may vary from 3 to 10, but that you have to calculate. I'm showing you the way to calculate it, right?
ओके सर।
Okay, then we'll apply that, assuming that our calculation is something around 3, and if you are not sure, you can go for 3.5. That is your decision. Nobody is going to say that how. You can say that, sir, as per my calculation it is 3.5, so I am considering 3.5. So let's say 3.5 and then apply. Now you can see it has been applied. Okay. Now this is bathroom. This is bathroom, which is normally 200 sunk. So in that case, let's say 0.18 into 200 will be 3.6 plus let's say floor finish and etc. 1.4. So 3.6 plus 1.4, which is 5. So you can apply STL in the bathroom as assign shell load uniform, and it will be 5. See, it's as per your calculation. Okay, so you have applied, and now if you right click, and you can see a 5 kilonewton in the form of STL is applied, live load is applied as 1.5. Then if you click on here, you can see 1.5 is applied and live load is 2. So you can check it, right? Clear?
यस सर।
And if you want to check the loading of all slab in a single view, then you will go to display, load assign, shell. In shell, you can go to live, and you can see whether live load is considered on every part of the slab. Yes. Forget about how much it is. So it varies from the project to project, or from designer to designer, or from code to code. But as we are following IS 456, I mean IS 875. So accordingly, IS 875 is saying this much load. Then if I want to see STL, again I will go to display, load assign, shell, and under shell I will go to STL and click OK. So I will see that. What I will check that whether nothing is left. Right? Clear?
यस सर।
Any doubt?
No, sir.
Okay. Now, this way you can apply the loading on every floor, or you can take the help of that similar story option. If the loading on floor to then you don't, you can club it in one group, or you can go to terrace. Now let's see, we'll go to terrace and see what are the things. Now let's say I will go to terrace. Yeah, so you can see this is the terrace slab, and at terrace, let's say everywhere I want to apply the live load, and on terrace, for residential terrace, when it is subjected to overcrowding, then you may consider a little bit higher, or in normal cases, the slabs on terrace are subjected to live load. I'm talking about Indian standards. Uh, for any other code, you have to refer the code, and accordingly you will have to apply the loading. So here you can see that under live load category, I will apply a live load in this shell load uniform. Then first I will apply live load, and then live load. If I apply, let's say 2.5, I'm just considering 0.5 additional over and above what is recommended by code. You can apply, and you can see everywhere it is applied. And now terrace, always there is a waterproofing load to be considered on terrace, and you can apply that waterproof loading under the category of STL. And then now I want to select all the things, so I can use that select get previous selection. So the selection is available, and under STL category, now let's say I'm applying a loading of 4 kilonewton, apply,
Apply.
and then right click. You can see under live load category, you have applied a loading of 2.5. Under STL category, you have applied loading of 4. So this way you will apply loading on all slabs, right? Clear?
Yes, sir.
So let's apply it at second slab also. So I am just going 1, 2, 3, 4, 5, 6, 7, 8, and 9. We will apply a live load of 2 kilonewton, shell load, uniform,
Uniform.
STL
Live load.
on the
2.5.
to apply. Then this 1, 2, and 3, I may apply a live load of 3, apply. Then 1, 2, and 3, I may apply a live load of 2 kilonewton. Assign shell load uniform, and live load of say 2 kilonewton, apply. So that has been applied. And now let's say I want to apply a floor finish of 1.5. So I will apply it on all floors. I'm just applying some loading under different category, but actually you have to calculate for each and every part, and you have to apply it. Okay, so I have selected, then I will apply loading shell load uniform under the case of STL. I will apply a load of 1.5 loads. Clear? So the loading is applied. Now what is remaining?
सर आपने फर्स्ट फ्लोर पर अलग लोड लगाया, सेकंड फ्लोर पर अलग लोड लगाया,
अरे
लगा
मैंने
सकते हैं?
सी नहीं वो हो सकता है ना, दैट इज एज पर दैट इज व्हाट आई वांट टू एक्सप्लेन इट टू यू. ऐसा नहीं है कि फर्स्ट फ्लोर पे जितना है उतना ही सेकंड पे. दैट इज द डिसीजन दैट एज अ डिजाइन इंजीनियर यू विल टेक इनटू. आई एम सेइंग इफ यू हैव टेकन अ डिसीजन हाउ इट विल बी अप्लाइड, whether it is correct or not, that will go when we will be going in practical model, right?
Okay, sir.
See, right now what we are exercising, let's say I want to apply this load, whether that is correct or not, that is different thing. But if I want to apply, how I will apply? समझ में आ रहा है?
यस सर.
प्रैक्टिकल मॉडल हम लोग लेने वाले हैं अभी. एक सेशन के बाद हम लोग प्रैक्टिकल मॉडल लेने वाले हैं। वहां पे मैं पहले आपको आर्किटेक्चरल ड्राइंग दिखाऊंगा, आर्किटेक्ट ने क्या क्या बताया है वो दिखाऊंगा, कॉलम क्यों लिए वो दिखाऊंगा, और फिर विल स्टार्ट क्रिएटिंग दैट मॉडल। देयर यू
ओके
कैन
सर।
आस्क मी सर ये ऐसा कैसा। यहाँ पे इतना ही देखोगा, अगर उतना है तो कैसे अप्लाई करेंगे, राइट।
राइट सर।
थॉट प्रोसेस पर कॉन्सेंट्रेट करो, मैग्नीट्यूड पे कॉन्सेंट्रेट मत करो। लोग उसी में अटक जाते हैं। अरे नहीं, वो दो इधर लिया, वहां पे तो दो 2.25 लिया, समवेयर एल्स 1.5 लिया, ये ऐसे कैसे। जो लिया वो मेरा डिसीजन है, वो गलत है सही है वो बाद में देखेंगे। समझ में आता है। सी यू हैव टेकन अ डिसीजन। बात आ रही है ना समझ में। मान लो आपको दिल्ली जाना है, नहीं क्यों दिल्ली जाना है, मुंबई तो नजदीक है। अरे नहीं है बाबा, मुझे दिल्ली जाना है, ये मेरा डिसीजन है। समझ में आ रहा है ना।
यस सर।
So if I have taken a decision based on my experience and my calculation, how I can apply and get the results. That is the point that we are discussing right now. We are not discussing whether it is correct or not. वो तो बाद में देखेंगे, right? Okay, so let us assume that everything is correct, and now we'll see the next part of this. Now we have applied the loading, and you can see under the defined category, under load case category, you will see that dead load, linear static, live load, linear static, STL, linear static. So we are going for linear analysis, and linear analysis. Uh, in this analysis, we can apply principle of superposition, and based on that, now we are going for load combination. See, finally, you are interested to know the maximum force. Clear? Hello.
यस सर।
सर
आपका ऑब्जेक्ट क्या है? मान लो if you are designing a footing, what is your object? Your object is to find out the maximum forces that are acting on the footing, and based on that you will design the footing. मान लो you are designing a beam. आपका ऑब्जेक्ट क्या है? To find out the maximum external forces that are acting on the beam, and then you will analyze that beam for that maximum forces. You will find the maximum bending moment, you will find maximum shear force, and based on that you will design the beam to resist that. Clear? You are not interested what is the force due to dead load, what is the force due to live load, what is the force due to STL. You are saying that okay, ये तीनों साथ में आए तो maximum force कितना होगा. That is the point that you are having interest, and that is under combination. So go to define and go to combination, and now here what are the combinations? For working load, what is the combination? Dead load plus live load. For limit state, what is the combination?
1.5
1.5
2
dead
dead
load plus
load
live load.
plus live load. And we are designing the beams or columns for this. And we are checking the serviceability criteria to follow this combination. And that's why both the cases are important. Now, if you are not defining the combinations, then this software will give you forces due to dead load, forces due to live load, and forces due to STL. And then you will have to make the summation as per this rule manually. But this is not necessary. That is not to be done by you, because software can do that also for you. But how it will do? Unless and until you give him the combinations. And these combinations are given to the software through the concept of define loading combination. Okay.
Yes, sir.
So you can go to define, click on it, go to load combination, and under this, add new combination. Now in this combination, you can name the combination as dead load plus
Live load.
live load. Okay.
Yes, sir.
Let me do it in capital letters. So dead load plus live load. Okay. So this is the name of the combination. Combination type is linear add. That means it will add by summation. What is you are going to define over here. And auto combination, there is no auto combination, and you can see a load case which is dead and scale factor is 1.
1.
Then I will go over here and I will create STL. Yeah, dead. Then I will click on
Add.
add, and now this I will convert it to STL. Okay, so STL will be having load factor, scale factor as 1. Then I will add one more and I will
Live
call
load.
it as live load, and the factor will be 1. So dead load will be multiplied by 1, STL will be multiplied by 1, and live load will be multiplied by 1. So this is my combination, dead load plus live load. You can click on that. So the first combination is defined. Second combination, I will define add new combination. And here I will say 1.5 in bracket dead load plus
Just live load.
live load, bracket complete. Okay. And then I will add, let's say now here I will change it to 1.5. The factor will be 1.5. This I will change to
Live
STL.
load.
First, pura dead load,
Okay, sir. 1.5.
and
Then live
then
load.
live load.
1.5.
Okay. And then I will,
Okay, sir. Add.
so it has been added. So 1.5 dead load plus live load, and dead load plus live load. These are the two cases that you need right now for gravity analysis. Now it is complete. Now this you have to go for analysis. Click on it. Check the model first. The model is checked for model errors. So you can click on that, everything. You can click everything manually, or you can click over here, select or deselect all. Okay, so it will select, and then click
Okay.
OK. Now the model will be checked whether there are some modeling errors. Now once it is showing that model has been checked, no warning messages. Now let me tell you, the software can check only for modeling errors. It will not check for your analysis errors. That means whether that 1.5 is correct, or whether that thickness is correct, or whether that beam is continuous, that is correct, or whether it should be hinged or not. That is all decisions. So the decisions which need imagination or which need experience or understanding is to be taken by you. Software will not take the decision for that. Clear?
Clear, sir.
तो सॉफ्टवेयर आपका आपका असिस्टेंट है, आपका बॉस नहीं है. तो वो आपको बोलेगा सब आप जो बोल रहे हैं वो करेक्ट है. आप बोलेंगे नहीं वो उधर नहीं जाना, वो बोले करेक्ट है. बोलेंगे नहीं नहीं उधर जाना है, करेक्ट है. So software will not advise you, or software will not verify you. Software will follow your instructions blindly. So अगर कुछ गलत है तो जिम्मेदारी आपकी है, सॉफ्टवेयर की नहीं. Clear? Yes.
Yes, sir.
Hello.
Yes, sir.
Now then why we are checking for errors? Errors means उसको पता है कि whether this beam is connected to this beam or not. वो आपको बताएगा. Whether one floor is overlapping another. वो आपको बताएगा. Whether आपने एक ही जगह दो तीन बीम किए है क्या, ओवरलैपिंग ऑफ द बीम्स है क्या, वो आपको बताएगा. डिसकंटिन्यूटी है क्या, वो आपको बताएगा. दैट इज कॉल्ड अ मॉडलिंग एरर. नाउ right now model says that, or software says that there are no modeling errors, then you can go for analysis. One more thing is that if the modeling errors are there, you have to correct the errors. Only then analysis can be carried out. Analysis cannot be carried out for all those models which are containing modeling errors. Clear? Yes.
Yes.
So unless you get that, see, unless I go to this, I go for check model and I ask him to check it, and he is checking. Unless this no warning messages were generated, ये विंडो आपका ब्लैंक नहीं आता है, तब तक आपको करेक्शन करना पड़ेगा. Right now there are no errors, so we can go for analysis. And now I will ask him to run analysis. So the analysis is going on, and you can see the software has done the analysis. And now you are through to the analysis, and now you can check the results. I will just show, but tomorrow we'll discuss everything about this results, and then I will show you. Right now I'm just showing you how I can check the results. Let's say I want to check the results for this B. Okay, I will go to that level. So that is something, I think it was x1. Okay, so that level was x1. So I'm showing it over here, and then I'm going to ask him force stress diagram, फ्रेम पियर डायग्राम, वो सारा चीज मैं आपको बताऊंगा. जस्ट मैं आपको आज दिखाने वाला हूं, कल इस पर बात करेंगे. ये देखो, ये उसने आपको रिजल्ट्स दिए. दिस इज बेंडिंग मोमेंट, राइट? इफ आई वांट टू सी इट, you can see this is shear force, this is bending moment diagram, and based on that you have to design that beam. Clear? Now if I go to another elevation, let's say I will go to elevation number 2. This is your bending moment diagram. ये ऐसा ही होता है ना books
Yes,
में.
sir.
Yes, sir.
So this is how the results are. We are getting the results. So you can see here now. So the bending moment at right support is 321. Then bending moment at left support is again 318. Then bending moment at center is something 152. So all that, and this is for 1.5 dead load plus live load. मान लो अगर मैं चेंज करता हूँ लोड केस, लेट्स से आई वांट टू सी द रिजल्ट ड्यू टू एसटीएल ओनली, then I will get it somewhere here. And now you can see the values are changing. So 85, 83, and this will be something around 40. So this is for individual load. So you can check for self weight. So for self weight, these are the bending moment and shear force diagram. And this is the deflected profile. Profile for what? You can see here diagram for beam 14 at story terrace, having size 230 by 450 M20, and this is that. Clear?
Yes, sir.
And if I want to see the axial forces in the columns, I can go to display. I can go to stress diagram, moment P up and roll, and here I will go for axial forces and for this. And you can see
Right.
apply. And these are the axial forces. ऊपर से नीचे बढ़ते गया है.
Yes, sir.
ये मैग्नीट्यूड के बारे में बाद में देखेंगे. बढ़ते गया है कि नहीं इतना देखो.
सबसे कम लोड ऊपर लगा, लास्ट में सबसे ज्यादा लोड लगा.
तो वैसे ही होगा ना.
Yes, sir.
ऊपर से लोड बढ़ जाएगा ना कॉलम में.
Yes, sir.
That means whatever we have done is correct. The only thing is that quantity, and based on that quantity will define the size of column, will define the reinforcement in the columns, beams, etc. Right?
Yes, sir.
सो यहाँ तक मैं आपको कहूंगा, यहाँ तक मैंने आपको जो मॉडलिंग में सारी चीजें हैं वो बताई है. You have to get a practice, and then from next onwards we'll start practical modeling. We'll go for one practical model that we have already constructed in Pune, and we'll see the architectural data, we'll see the GA arrangement, everything, and we'll create the model and we'll design it. Right?
Okay, sir.
Yes, sir.
तो प्रोसेस सही चल रहा है कि कुछ चेंज करना पड़ेगा?
सही चल रहा है सर.
सही चल रहा है सर.
ओके, थैंक्स फॉर दैट. देन आई थिंक आप लोग थोड़ा जितना प्रैक्टिस करोगे उतना अच्छा रहेगा. एंड विल स्टार्ट विद देन एक्चुअल मॉडलिंग फ्रॉम डे आफ्टर टुमारो. यही सब रिपीट होगा, but that time I will give you the practical considerations, sizing, etc., then designs, and we'll carry out the entire design for, and then we'll go for lateral load analysis also, and then we'll apply earthquake, we'll apply wind if I get a time, otherwise we'll apply the live earthquake loading, and dynamic loading also we'll see, and all combinations we'll see, and some concept about lateral load analysis, how it is different from gravity analysis, what are the main considerations, all that thing we are going to discuss. मैं आपको परफेक्ट बनाना चाहता हूं. I want to introduce you in a practical field where you will work hard, and within 1 or 2 years you will become a confident structure engineer. So ये मेरा एम है. अगर आप लोग साथ देंगे तो डेफिनेटली वो आगे, हम लोग आगे जाएंगे. तो साथ देंगे कि नहीं देंगे?
देंगे सर.
Yes, sir. बिल्कुल देंगे.
Yes, sir.
So,
100%.
yeah, ठीक है. And the sessions will be enjoyable. Don't worry about it. वो बोर नहीं होना चाहिए.
तो इसके अंदर सॉइल प्रेशर भी कैलकुलेशन होगा ना?
Yes. या
सॉइल प्रेशर कैलकुलेशन, कितना सॉइल का प्रेशर,
लैटरल लोड का.
यस सर.
वो तो बाद में करेंगे, पहले ये तो बेसिक कर लेंगे ना.
ओके सर.
See, soil pressure, see, other things are, see, once you understand the basics, then application of advanced concept is very, very simple. You don't need any advisor. Believe me. Agar, see, why we are needing advisor? Because we are lagging somewhere in basic understanding. So I will try to clear your basic understanding. How you will think in situations, what is the base, and why you are confirm with that. तो कॉन्फिडेंट जो है ना वही आगे जाता है. Right?
Right, sir.
So I will again give you one example. See, whenever you are not performing, maybe in sports, maybe in your domestic life, or maybe in your career, अगर आप ढंग से परफॉर्म नहीं कर रहे तो समवेयर यू आर लैगिंग इन बेसिक्स। तो बेसिक पर वापस काम करो एंड यू विल स्टार्ट परफॉर्मिंग अगेन। क्लियर?
क्लियर सर।
एडवांस सीखने की जरूरत नहीं पड़ती है, एडवांस कुछ नहीं होता, बेसिक पर ही सारा चीज डिपेंड होता है। क्या होगा यार, एक बार आपको लैटरल लोड अप्लाई करने आए ना तो बस थोड़ा सा एक दो बुक पढ़ना है और वो उसका लैटरल लोडिंग का मैग्नीट्यूड कैलकुलेट करना है, वो देखना है। राइट?
राइट सर।
Yeah, but I will appreciate if everybody of you start speaking with me. हो रहा क्या कि अविनाश कुमार ही ज्यादा बात करते हैं, अभिषेक शर्मा बात करते हैं, बाकी लोग बात नहीं करते। क्यों नहीं करते ये मेरी समझ में नहीं आता। अगर आपको कुछ चीजें, सी देर आर टू थिंग्स, either you may know it everything, you know everything, or you may not be following what I am saying. But if you are not following and if you want to get it clear, then please ask me. अगर आप पूछेंगे नहीं तो मुझे नहीं समझेगा कि आपको समझा या नहीं समझा। क्लियर?
क्लियर सर।
सो मे बी हा शहाजी पाटील बोलायचं थांबायचं नाही।
ओके सर, ओके.
हा ओके, द सेम थिंग शिवनारायण। या यस
सर एक्चुअली शाम में जब क्लास शुरू होती है मैं रास्ते में होती हूँ ऑफिस से और
ओके।
मैं बहुत लेट पहुंचती हूँ घर, तो मैं नेक्स्ट डे ही देख के मैं नेक्स्ट डे ही प्रैक्टिस करती हूँ सर, इसीलिए मैं बीच
तो
में से
आप
रिस्पॉन्ड नहीं करती।
उसके बाद पूछिए ना, ऐसा तो नहीं है। यू कैन आस्क मी, सी व्हेन you are joining, you may ask me whatever you have learned in the previous recorded session. You can ask me in that live session also, or we'll have some 10 to 15 minutes at the finishing. We can discuss. मेरा कंसंट्रेशन इस पर
ओके
है
सर।
कि हाँ, मेरा कंसंट्रेशन इस पर है कि आप लोग पीछे न रह जाए। राइट?
सर एक्चुअली मैं इसलिए पूछ लेता हूँ क्योंकि मैं आप जो प्रैक्टिस करवाते हैं वो फिर मैंने पहले से भी कर रखा है प्रैक्टिस, प्लस मैं 2-4 राइटर का बुक पढ़ता हूँ, मैं इसलिए आपसे पूछ लेता हूँ।
नहीं, वो बहुत अच्छी बात है। यू आर द लीडर ऑफ एंटायर बैच। पूछते रहो, उनके हिसाब से कुछ चीजें पूछते रहो, क्योंकि हो सकता है कुछ तो शायद होते हैं लोग पूछते नहीं। मैं आपको एनकरेज करूंगा, 4 और क्वेश्चन पूछ लो, 2 ही क्यों पूछते हो। राइट?
राइट सर।
see why, because see many times what happens, मेरे मन में सवाल है मगर मैं डरता हूँ कि यार लोग हंसेंगे तो नहीं, तो इसलिए मैं नहीं पूछता हूँ। तो यू
सर
कैन
मैंने एक चीज सीखा है कि जिसको हंसना है हंसने दो, मुझे जो आता है मैं जानता हूँ कि मैं अभी पढ़ रहा हूँ तो मैं 0 जानता हूँ।
राइट।
मैं बेशरम बन जाता हूँ सर पढ़ने समय, जिसको हंसना है हंसने दो।
सी मैं लोगों को हमेशा कहता हूँ, अगर अगर आप पढ़ते समय अपना ईगो साथ में लेके आए ना, तो यू विल नेवर अंडरस्टैंड द थिंग्स। you're on my track, मुझे ऐसा लगता है, क्योंकि मैं लोगों को इतना परेशान करता था। लोग बोलते थे अरे ये आया यार भागो, ये बहुत बोर करेगा, वो कुछ भी पूछता है। मैं बोलता हूँ यार तुम्हें पता नहीं है तो ना बोलो ना, मैं दूसरे को पूछता हूँ। नहीं मुझे मालूम है, तो फिर बताओ। फिर वो ऐसा ऐसा उधर उधर कुछ बोल, नहीं मैं बोलता हूँ ये गलत है, सही आंसर बोलो। फिर बोलता नहीं यार सही मुझे भी नहीं मालूम। तो फिर मुझे क्यों हंस रहे हो अगर तुम्हें भी नहीं पता तो। मैं उनको ऐसे बोलता था। हाँ, हंसने का चांस है अगर इफ यू नो, देन यू कैन लाफ एट मी दैट आई डोंट नो। मगर पता तो तुम्हें भी नहीं है, फिर क्यों हंस रहे। फिर वो बोलते थे यार नहीं ये आदमी बहुत बोर करता है। सो इवन माय प्रोफेसर ऑल्सो, अरे कितना पूछोगे। मैं बोला सर जितना मुझे आता है वो चाहिए उतना सारा पूछूंगा। आपको नहीं बताना है तो मत बताओ, मैं किसी और को पूछूंगा, मगर पूछना मैं नहीं छोड़ूंगा। ये मेरा तरीका ऐसा था, एंड दैट्स व्हाई आई वेंट थ्रू। फिर कुछ प्रोफेसर्स ने मुझे बोला नहीं नहीं ये सारी सवाल का जवाब मैं देने के लिए बाध्य नहीं हूँ, मगर मैं तुम्हें एक डायरेक्शन देता हूँ, ये बुक पढ़ लो। मैं बोलता था ठीक है, वो बुक पढ़ लेता हूँ, तो वहां पे मुझे आंसर मिलता था। मगर पूछना जरूर, अगर आपको सीखना है तो पूछना जरूरी है। अविनाशी जी ऑन राइट ट्रैक। मैं कहता हूँ बाकी सारे लोगों को भी, आई विल से दैट यू शुड फॉलो व्हाट अविनाश कुमार इज फॉलोइंग। ओके
सर मैंने ये चीज कहाँ सीखा, मैंने 400 साइट पर काम किया
राइट।
एज ए फ्रेशर, मैंने एज ए फ्रेशर वर्क किया, तो मुझे कोई सीनियर नहीं बताता था। तो मैंने एक चीज किया, मुझे जो नहीं है मैं यूट्यूब पहले देख लेता हूँ। यूट्यूब से नहीं था, मेरे कॉलेज के सीनियर थे, उनसे मैं बात कर लेता था। मैं 2-3 जगह से नॉलेज लेके फिर मैं वो चीज अप्लाई करता था। तो मैं
राइट
समझ गया कि जीवन में कोई अगर जो कुछ लोग होते हैं नहीं बताएं, लेकिन आप जहाँ इन्वेस्टमेंट कर रहे हो ज्ञान के लिए, वहां अगर बेशर्म नहीं बनोगे तो आप कुछ नहीं पा पाओगे।
बराबर बराबर, ये बिल्कुल बिल्कुल, आई एग्री विथ यू 100%, not 99%, 100%, because I have followed that method, and I'm saying to all others also, follow that method if you want to learn the things. That is the only way how you can learn. See, you cannot learn all the things from one person, क्योंकि किसी भी एक इंसान को सारी चीजें कभी पता नहीं होती। मैं ये कभी दावा नहीं करूंगा कि मुझे सब आता है, मैं भी आज भी सीखता हूँ। आई ऑल्सो रीड द बुक्स। मैं वो आपके साथ शेयर करूंगा। मेरा काम इतना ही है कि जो मुझे आता है वो मैं आपके साथ शेयर करूंगा। उसमें से जिसको वो लेना है वो लेगा, जिसको नहीं लेना है वो छोड़ देगा। राइट?
राइट सर।
Okay. So with this, we'll conclude today's session, and next session we'll be discussing lot of good things and lot of best things. So be prepared for the next session, because there I am going to explain you some basic concept how to read the results and how to interpret the results. What is the meaning of that? And if you do not want that result, what you have to take care in the model, how you can correct and get whatever you need. Okay. So then uh, next session will meet at 7:30 day after tomorrow. Thank you.
थैंक यू सर। गुड नाइट
Good
सर।
night.
Yes, sir.
Thank you,
Good
sir.
night. Good night.
Thank
हॅलो
Yeah.
सर, एक विचारायचं होतं. स्लॅब सेक्शन डिफाईन करतो ना आपण,
Hmm.
तर त्याच्यात ते शेल मध्ये आपण शिकलो होतो की इन प्लेन आणि आउट प्लेन दोन्ही फोर्सेस घेतो.
Hmm.
तर त्याच्यात त्यांनी थिन आणि थिक असं ऑप्शन होतं. मी स्लॅब डिफाईन करत होतो तर ते काही डिफरन्स म्हणजे थिकनेस
थिक
वरून
नाही
आहे?
वापरायचा सध्या, थिक नाही वापरायचा. मी सांगेन
अच्छा,
थिक कधी वापरायचा.
ठीक आहे सर. आणि
हा,
सर ते ग्रीड लाईन आपण मॉडिफाय करतो, त्याच्यात ते स्टोरी डेटा मॉडिफाय करतो ना, तर
हम्म,
त्यात एक हे ऑप्शन आहे, सिमिलर स्टोरीच्या पुढचं जे ऑप्शन आहे स्प्लाइस स्टोरी, ते काय आहे?
नाही नाही, स्प्लाइस इज यूज इन स्टील स्ट्रक्चर,
अच्छा,
and the meaning that I will also explain in next session. But in reinforced concrete, we are not going to use that splice section.
ओके सर.
That is used only in steel structures.
ओके,
Yeah.
ठीक आहे सर. थँक्यू सर.
Oh, yeah. Thank you.
Excuse me, sir.
Yeah. Sulekha ji, go ahead.
Yes, sir.
Yeah.
Yes. So here, most of the projects we have flat slab. So
That's
I doubt, yeah. So I doubt how we are going to give this loading for the wall in the slab, like area load, like shell load we are giving, or we do as partition, means UDL.
Okay, actually, see what is happening in our session. We are not going for flat slab, but I will give 2 or 3 sessions later on for going in that flat slab sections. Because the concept, yeah, definitely, in Middle East, all the structures. They are going with beamless structures that are they are using PT slab or flat slab or column capital, and then the entire system is a little bit different than residential buildings with conventional residential buildings, slab supporting beams, then columns and footing. But you can use ETAP for that. But just I will have to talk to Anil sir, and we'll extend these sessions for 2 to 3 sessions. We'll carry for that, and then in that session I can explain that. But right now the entire syllabus is based for uh, the requirement which are in Indian market.
Yeah,
But
okay, sir.
but definitely will not say that we are not going to. We'll make the arrangement, but for that this session should go on ETAP, and then we'll carry out 2 to 3 sessions, and if you need additional one more session for that
Yeah.
flat slab and other things.
Yes, sir. Yes, the load applying means method may be different, but result reading may be okay after means analysis.
Yeah.
Yeah, we follow American code now here.
Yeah.
So,
In Middle East, but I think they are following ACI as well as British code.
yeah,
But
before British code was following, but now 2 3 year they means before.
they
Yeah.
shifted to ACI.
Yes. Yes. Mostly.
Yeah, ACI 318.
Yes, sir. Yes.
Actually, I'm not very conversant with ACI code because I'm not using that. But I
Mm.
know that. But the concept are not much different. The only thing is that unit system is different. Keep inch and
No,
thickness
sir.
is
We are using SI. It means metric. We practice metric.
SI system.
Yes.
Okay, then let me.
Only we need some idea for how the loading. Maybe that's only different. But and after analysis result, we can go with the same pattern, no, for Indian or solid slabs.
Okay, that can be completed within 2 or 3 sessions, and we'll definitely take care of that. Don't worry about it.
Okay, sir. Thank
But
you.
it will take a little bit time, maybe 1 month after.
No problem, sir. It's okay.
Yeah. Okay.
Thank you, sir.
Thank you. यस, और किसी को कुछ पूछना है? शाहजी ने तो पूछ लिया, मुकुल, केतन. Yes, anybody? अरे आप, yes,
No, sir.
Nikhil Kumar, you want to ask me something?
No, sir, not yet, sir.
Okay. So if you have queries, then you can talk to me. Otherwise, I'm going to conclude, and
Yes.
I'm closing.
Okay.
Okay. Thank you, sir. Good
Bye,
night.
sir. Good night.
Thank
Good
you.
night.
Good night. Good night.